So she's 15.
She don't look like 15.
And that's a good question. No, she's not pregnant. So but she's sick. She's sick. She has a flu, yes. And then I don't know, she doesn't like her school anymore. Yeah, I think. So
Homeschool.
that's what she said. I actually tried one semester and then we were fighting so bad. Like I was worried maybe one day I might, so it's not good to homeschool. Yeah, you never teach your own kid because I have more patience with other kids, not my own kid. Especially like if she doesn't know something, I'll feel like, how come like how come my gene doesn't pass on to you? Like this is so easy. And then she's like, and then I just get angry. So okay. So did you do quiz 2?
Yeah. Then you
Turn it in.
Oh, you wanted us to print. Oh, I didn't print it out.
What did you do?
I just wrote down the answers on piece.
That's fine. Do you have the piece of paper? Don't forget to write down your name.
I wrote my name.
Oh,
This is quiz 2.
you have the histograms and everything, right?
Oh, okay. Yeah. Okay, it looks okay.
I knew this was-
Oh, thank you.
Okay.
Yes. We can submit, if you submit to Dropbox, make sure it's in the right direction. Don't tilt anywhere, okay? If it's in this way, or this way, I won't grade it. Because my printer sucks. So it took me last time almost 1 hour to print out the whatever, like if you take pictures,
You have a Steve versions?
it's okay.
This one.
Okay. Hold it and then, yes, and then I will,
I didn't like this. Is there a Dropbox?
yeah. Say,
I
and
know
then
it's a Dropbox. How much you get like that?
send, is it a touch screen computer? Is it a touch screen computer? How did you do this?
Like this.
Oh, okay, I thought you. Thank you. Okay, so you guys know what is discrete and continuous, right? And we know what descriptive, what is inferential statistics. So descriptive statistics is to describe the data. Okay, did I worry?
There you go. Oh. Yeah.
Okay, I did. I have staples, okay. Oh, there's a,
I just
did you put your name?
yeah,
On it?
my name, I put my name in the piece.
Okay. Okay, good. Okay. So we are going to, this is like up till chapter 3 are all easy, okay? So we are going to measure the central tendency and then the variability, so use average, mean, and standard deviation, and then the group data, like, we kind of talk about how to put data in a group, okay? And then we will measure the relative position. So someone put a chat. Quiz 2 are due today. So let me make it smaller. So when we have histogram of the height of US adult, so the central tendency, so here is like 70 inches, okay, 70. It's 6 feet, right? Yeah, 6 feet. A little bit less than 6 feet. Yeah. And, so we use three measures to kind of measure the central tendency. We use mean, the average, we use the median, which is the middle point of the data, and then we use the mode. Mode is the majority of the data, okay, three M's. And let me see. Okay. So to calculate average, anybody doesn't know how to calculate average? Everybody knows, right? So you add up the whole data divided by how many numbers you have. Okay, so that's the average. And then, you know, here I just want to show you some of the symbols we use. So for populations, the sample size, how many data we have, we always use capital letter N. And then for sample, we use small letter n. And then for the population mean, we use mu. Mu, right? Like mu. And then for sample, we use x bar. Can I write it? Oh no. So. We use. Well. We spent $10,000 in this smart board, it just never worked.
You gotta recalibrate it.
Huh?
Recalibrate it.
How?
Some button on it.
X bar, yeah, okay, that's X bar. Yeah, so it should be, like, I remember if we reset it, we can, you know. Okay, so. The average income for 5 randomly selected families. So 87.2 thousand, 118.9, 76.2, 107.7, 61.5. So we have 5 different information, 5 data. So we just add it up, divided by 5. So average is 90.3 K. Okay. If it's a population, then we change the small n to large n, and then change x bar to mu. So that's the only difference. But sometimes it's important in statistics. So, and then we have the weighted mean. So basically, it depends on, you know, different weight, and then we use the weight times the number, the data, and then divided by the total weight. So I'll show you. So like when we calculate GPA. Okay, here. So Tom's final grade. Okay. I like to use Tom because Tom is my ex-husband's name. So I can criticize Tom. So exam, he got 94 points, project 92, homework 100, and they have different weight, 50%, 35%, 15%. So to calculate the weighted average will be 94 times 50% plus 92 plus times 35% plus 100 times 15%. Okay, that's it. Very simple. And then divided by 100%, so it's still 1. Okay. So that's it. 94.2, A plus. So so how about this one? So if we have a student 1, okay, he has three
Two.
Huh?
Two.
Why?
Cause he's consistent.
So this one is 80. Okay, 80 average. This one also average 80. Which one will you pick? You pick 2. Well, how many of you will pick 1? If you are student 1, I mean, if to go to a competition, 6, 80 and 100. Which one will pick student 1? Nobody? Which one pick student 2? Okay. Few people pick student 2. Why? You say he's consistent? I probably, I don't know, if I want to win, I probably pick student 1.
That's gambling.
I like gambling. So because he might be getting 100 and he will win.
Or he might get that 62.
Yeah, but if you get 80, there might be some people have like 90 or 100. He will never beat those people, right? So, so I don't know. I mean, it's so this one, this just the average doesn't really show anything. I mean, it will show that okay, the average is 80, the same, but we want to know more. Okay, if we want consistency, how do we see? How do we find like how do we calculate consistency? This one is easy. This one is easy. Imagine we have thousands of data. How do we look at consistency? Okay, and then also sometimes we might have outliers like here. The height of student male. Okay, so this one, the average is 72.5, but there's actually someone, the height is 80 inches, which is what? 6'8". 6'8" is not, it's okay, but it's very tall, okay, 6'8". So one person is 6'8", so that's the outlier. So then actually the outlier make the average height a little bit higher than it's supposed to be. So this shows that the average height is like almost 6 feet and 0.5. 6 feet, 0.5 inches, okay?
You got 7.
Is it 7? 6
No,
times 12, yeah, 6. 6.5 is 6, is it 6? Okay, yeah,
you're right.
okay, so to use just average, sometimes those are the disadvantage. We might be biased in something. So median is the number where the half in the middle point, okay? Half of the observations are higher and half are lower, so it's in the middle, okay? So that's median. So, so like in this case, so when we are calculating median, we always have to arrange the value by, by the order. It could be ascending or it could be descending. It doesn't matter, but we have to kind of put it in the order so we know what is in the middle. So this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the middle point of 9 is if you 9 divided by 2 is 4.5. So you just round it up. Okay, so it will be 5. So the fifth number here, this number is the median. So if you see here, this number have 4 number lower than it, and then 4 number higher than it. So this is the median. Okay, but what if we have the odd, the even number? Okay, so this will work when it's the odd number in the middle, and the even number will have. So in theory. So in theory, the median is here, right? In the mid. Oh man, I have to do my magic. So the median is here. This is so far. It's in the middle of this because 5 numbers below and then 5 numbers above, but we don't know what is the value there. So we use these two. We use the average of these two, which is what? 84.5. Okay, so 84.5. So that's the median. Okay. And then the mode is whatever happened the most has the highest frequency. So like here, the quiz score, we have 5 out of 5 quizzes. So the mode is 2. Okay. And then if this, like this one, the value only appear 1 time, there's no mode. Okay, everybody is mode, so there's no mode. So so for data, you will get the average. you get medium, but not necessarily, you don't always get the mole, it's a typo here, okay? Oops. Yeah. Okay, so what about this? So what is the mole for this one? I don't know why I have typos. See my cat. So what is the mole here?
One, oh wait. I don't know.
1 and 2, okay, 2 moles. 1 and 2 both are mole, so they are both, yeah. And then we have the frequency distribution. You guys feel this room is hot? Okay, I thought it's me.
You moving around a lot too.
Yeah. I've been doing this special jogging that make me more energetic. So it's like they call monkey style jogging. So basically you lean your body forward. So your weight will be on the, how do you call this?
The ball.
The ball of your feet. And then you move your butt, you lift your butt a little bit, and then you do this. Just do this.
You do that in public?
No, at home. Huh?
In place?
Yes, in place.
Oh.
And then 30 minutes, I sweat like crazy. And then I
Breath
won't
for
be
30
out of,
minutes.
I won't be out of breath.
You do that in the same spot for 30 minutes.
Yes, but sometimes my dog will bother me, so I have to throw a ball. And sometimes I will move around a little bit. But you do this. Try it if you have any, like if your feet or hand gets cold, it helps a lot. Like now,
Treadmill?
Hmm?
You just get a treadmill?
I have a treadmill, but but I heard like my friend was sharing it, and they say like some old lady, they have old gray hair, and then when they do this, they started to grow black hair. So they show photos. So I thought, okay, let me try it. And then I used to have really like bad back pain, and I have very stiff neck the last few weeks. And then when I only did it for like 3-4 days and it's gone.
That's the Mandela effect.
So that's why I keep doing, and then I feel more energetic now, like I don't get tired now. Before I'm always tired. Now I'm good. So yeah, but it's hot here. So we can use the frequency distribution, okay, to show to show us the mean and median, okay? And then we can see like it's how the data looks like. So when we have a median larger than the mean, so you see here, because we have some data that's higher value here, right? It's larger, they have higher frequency here. And then they have, so the median is here. But we also have some data like have longer tail here. So the mean is smaller than the mean. The mean is here, the median is here. So when we see this is called left skew. Okay, and then when we have a median smaller than the mean, because majority of the data has smaller value. Okay, so the median is actually here. And then the mean, because we have large data here, so the mean is gonna be higher. So when this happens, that's a right skew. Okay, so what kind of data usually have right skew? Majority of the data is like at the lower end, and then very few are in a higher end, but it's here. What is this? What, when you see this, what comes to your mind?
I don't know the right answer.
There's no right answer, just something I want you guys to think. Yeah,
Steps.
the what?
Steps.
Steps.
Looks like stairs.
Stairs. Well, yes, in this case, but the income. Okay, so we have people with higher income, smaller population have a lot of higher income, and majority of people are in the lower income. So that the average income is high, but actually 50% of the US population, their income is lower than the average, right? Okay? So that's this. And then how about this? Hopefully this will be your statistic grade, okay? So a lot of people have good grade here, only few exceptions have lower grade, okay? So that's the left skew and right skew. So use Excel. We can use Excel to just type in equal. So when you use Excel, make sure you always type in, when you type in equal, Excel knows you are going to put in some formula. So equal, and then we can just put in A, B, E, and then they will pop up the formula and the median or more. Okay, and then you select whatever you want to calculate. So that's the easiest way to do. Or we can go to data analysis, descriptive statistics, and then we would select the input range. Okay, and then we put the output range, like where you want to put that descriptive statistic. And then we can do summary statistic. Okay, so that's the Excel. So yeah, so this is like this, you can select this range, and then they will show us. And then this is the old version. So mean is easy to use, okay, and median won't be affected much by the outliers because you always find just the midpoint. The mean will be affected by the outliers. And then the mode will be a good measure to show us the central tendency. Whether or not, that the middle category has the highest frequency. So you have to do this. So this one, the average number of no-show per flight. So this means like 0 no-shows. We have 37 flights has 0 no-shows. Okay, 31 have 1 no-show, 22, and then 6, 3, and then 12 flights, 4, and then 4 flights will actually have 5 no-shows. Okay, so how do we calculate that? The no-shows. So basically 0 times 37 plus 1 times 31 plus 2 times 20 plus 3 times 16, 4 times 12, 5 times 4 divided by this. Okay? Did I talk too fast? It should be, yeah, this should be. So let me see. Oh, I don't have the answer. Okay. So we have to do this. So do this. 0 times 37 plus 1 times 31 plus 2 times 20 plus 3 times 16, 4 times 12 plus 5 times 4 equal 31 plus 40 plus 48 plus 48 plus 20. Did somebody already calculate it? 60, 96, 156, 156, 187 divided by, oh my God, 37 plus 31, 68, 68, 88, 88 plus 20, 108 plus 12, 120. Right?
Our mathematician isn't here today.
Oh my God, anybody calculating it? So 1 point something. $1.56. So the average number is 1.56. Let me see if I calculate it right. 37 plus 31 plus 20 plus 16 plus 12 plus 4. Yeah, 120, okay. Yeah, so this should be close. So average number of no-show is 1.56. Okay, and you can see, and then what about the mode? Where's the, I mean, the median, where's the median? 60, right? So the median is also like here, 1. Between 1 and 0. I mean, it's in 1. Okay, median is 1. 60, right? 60, 65. Oh, that's close. So how about this one? The housewife spend in chores on the weekend. So we have to, if we want to calculate median, we have to put it in the order, right? So what is the smallest number? 26,
And then 28,
28, 31,
39,
39,
43,
43,
45,
45, 45,
50,
50,
57,
57, 62. So is it how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median will be here, right? Here, we will have 5 below and 5 above. So this will be, the median will be 44, the average of these two. But the mole is 45, right? Mole only appeared twice. The only number appear more than once. How about this one? Negative, negative 12, negative 7, 10, 18, 25, 34. So the median will be here. The median is 14. Median is 14. The mode, there's no mode here. How about the average? So negative 19, 28, so it'll be positive 9. And then plus 25, it's 34, 34, 68 divided by 6, 11.3. Okay, so the average is 11.3. I think. So that's it for that. And then remember, when we talk about average, the students 1 and 2. Okay, 1 gets 60, 80, 100, 1 get 80, 80, 80. So we need to use the variability to check, you know, how variant
what variant?
variant their records are. Okay, so we have range. So like in that example, it will be
Oh,
the first
variant.
one range will be 60 to 100. And then the second one, the range is 0, like 80 to 80, so it's 0. And then the first one is like 40. So the variance, we have a way to calculate variance, and then standard deviation. So here is so the range is basically the largest number minus the smallest number. Okay, it's easy to use. Yeah. But sometimes when we have variance, sometimes when we have an average and when we calculate variance, sometimes the number will be larger, sometimes the number will be smaller, right? And if we just use the range to the average, sometimes it will cancel out. So we want to use the variance. So the variance is the difference of the data with the average, and then we take the square of the data, so that when we have negative number or positive number, it will all be positive because we squared it. And then we divide it by n minus 1. when for the sample. And standard deviation is the square root of variance. Any questions? This one you should, I hope you guys know. Do you guys know standard deviation and variance? Okay, good. So let's do this one, the variance.
I'm not doing a calculator.
Yeah,
I'm
if
talking
you,
about deviation.
so the calculator should be easy, right? You just need to input the number and then boom, put in the number. So I just want to show you how to do it first. So we need to calculate the average first. Oh, I can't even remember the one number. 10. So what's the average? Divided by 5. So what is this? 50, 80, 140, 175. 80, yeah, 175. Divided by 5. 55. 55.
You need a calculator?
Go with 75.
35, right?
Yep.
35, yeah, divided by 5. 35. So mean is 35. Is it? Yeah, it makes sense. Okay, so this is the mean, and we want to do the xi minus x bar, right? So this first one, this is the first xi, so that's 0. Second one is negative 25. This one is positive 15, and then negative 15, and then positive 25. Okay? So if we just look at the range, the difference, and we add it up, it will be 0. So we need to square it. So xi minus x bar squared. 0, 625, 225. It should be, yeah, this should be correct.
You can't just do all that on a calculator.
Huh?
You can't just do that on a calculator.
Yeah, do it. I don't have calculator.
Oh,
Did you do it?
no, I thought she was expecting us to do it by hand too.
Oh, no, I want you, oh, you mean the standard deviation? Or did you add it up?
I ain't do nothing. I was asking.
850, 850. 700. So this is the variance without dividing the n minus 1. So we do this divided by n minus 1, which is 4. What is this? 425, right? 1700 divided by 4. Is it 425?
It must be.
Huh?
Alright,
Come on. What time is it? So we still have time. 425. And then this is the variance.
yeah, it is.
And then the standard deviation will be 425 square root. Do you want me to, so it's what, 20?
I don't got that on my calculator.
20, you don't have the square root, 22,
I like,
maybe a little bit smaller, 21. I think it's like close to 21. Let me use my calculator. You can, when you flip, you can do square root. 425 square root. Oh, 20.6. So that's the sample variance. Oh, we just need to find variance, 20.6 standard deviation. Okay, and then we can use Excel as well.
Excel do all that?
Yeah. You can use Excel. Oh, see? Why do I do this? I forgot I have this here. So variance is 425. And then the shortcut. I can never remember this formula, so you guys have to, you can look at, we have a take-home exam, so you can use this. But I will not ask you guys to do this,
Good.
like by hand, okay? So this is a shortcut, now this is the normal formula. But you see the difference for population, we divide the population variance divided by the N. But for sample, it has to be a -1 for bias, because it's smaller sample, okay? So that's the only difference. And you can see that also on Excel. On Excel, they will ask you, is it a sample or population? So you need to make sure you select the right formula for Excel. So this is the shortcut. Then we don't have to worry about that. And then we have so even with the variance and the standard deviation, it shows us how dispersed the data is, right? But sometimes, let's say if I have a student. Where's my, so let's use the example there. Oh, well, that's not good. So let's say if I have, data, the average x1 bar is 50, and then the standard deviation is, this is the one, is 5. Okay, and then I have another data, x2 equal to 100, and then the standard deviation is 7. So what if that's the case? Okay, so can we say this data has smaller dispersion, or this one has bigger dispersion, this bigger variation for the data? So that's when we need to use the coefficient of variance. So it has to be the relative term. So because this data, the average is bigger. So even though the standard deviation looks bigger than this one, but the coefficient of the variance will be, like in this case, will be 5 divided by 50 times 100%. So this one will be 10%, and this one will be less than 10%, 7 divided by 100, 7%. Okay, so the coefficient of variance is smaller here. So we measure the standard deviation in terms of the percentage of the mean. Okay, so the variability is actually higher for this one, even though the standard deviation is smaller. Okay, but compared to the average, the variation is actually bigger. Okay, so that's why we need to use coefficient of variance. So like this one, which one is more consistent? The average of 55.62 with standard deviation of 5.1, or 24.86, the standard deviation 3.6. So that's when we need to use the coefficient of variance, okay? Let me see if I have, yeah, I have answered. So the first one is 9.2%. Second one is actually 14.5%. So even though this one, the standard deviation is bigger than this, but it's actually more consistent because the average, the mean is bigger, okay? So any questions? Okay, so, we do this. Let's do it in Excel. So I don't have to do the calculation. Nobody helped. Nobody help me. Happy,
When she comes back, she'll help.
push. Oh, yeah, I didn't know. She didn't show up.
Yeah.
So how many data I have there? 8. See if it will work. Paste. Oh, I can do that. So well. Ah. Did I do? It's stupid. And it takes the number. Yeah. Okay, well, okay. I'll just type it in then. So 32, oops. Thirty-two, 40, 27, 29, 34, 38, 46, 24. So what do we need to calculate?
Didn't it say like standard deviation or something like that?
Yeah, standard deviation, variance, coefficient, okay, so standard deviation, we can do standard deviation. So you see here. Let me select the third one, so you see, standard deviation based on a sample. Okay, and if we do. Well, let's just do this. Okay, so let's click here. Click and then select all the numbers. So that's that, standard deviation. Okay, what? And then variance for sample here. Okay,
Like that.
yeah. If we don't trust the Excel, we can try to do,
But why would you not trust Excel?
because I don't know, average, and then we need average. So what is coefficient? So this is standard deviation, this is the variance. And then this is the mean. So the coefficient of efficiency, coefficient of variance is what? The standard deviation divided by the mean, right? So this is coefficient of variance. And then we have to do it in a percentage. That's it.
Wait, can you rewind that last part out, CV?
This one,
Yeah,
so just standard deviation divided by the average, the mean. Okay? So that's that. So let's see. Ah, wait, this is, oh, yeah, this is the average. Okay, yeah,
Is it variance of the sample or?
yes, so this is a sample. So you do variance for variance S for sample. Yeah. Oh, and then we need to convert when we are trying to figure out.
We still going?
Yes, what time is it? We still have 25 minutes.
Oh,
We still have 25 minutes. So we need to, even with the average, the standard deviation, you know, we need to standardize the data, okay? So now, when we try to calculate the variability, how far away, how dispersed the data is, we don't use the numbers, we use how many standard deviation is this away from my data, okay? So we calculate the distance, and then we use the distance divided by the standard deviation. So when we have the number that shows how far is it from our mean, from average, what is this number mean? How far is it from our average in terms of how many standard deviation? So if the z equal to 1, that means it's in 1 standard deviation range, okay? So x minus x bar divided by standard deviation, that's a z value. For population, same thing, just different symbol. X minus mu divided by sigma. Sigma is the population standard deviation. So that's the z value. So the z value, we can, when we convert stuff into z, we can use the normal distribution table to figure out how far is it from, the average. So, and then in Excel, we can use different what is it? Formula. So the standardized, we can put in X mean and then standard deviation, it will calculate the Z score for us, okay? And for the sample, we already know the variance. We do the variance dot S and then standard deviation dot S. And then the population is variance dot P, standard deviation dot P. Okay, that's the population. So those are the how we calculate sample and population numbers with Excel. And we will use more Excel in the future. So now we we still calculate stuff by hand. So you have the concept, like why, what does that mean,
Who still calculate by hand?
No, I don't calculate by hand, but I want to show you how to do it by hand, so you know what exactly that means. Where does this come from? Okay, you
Well-
don't have to,
Okay,
you don't have to memorize, but you
Yeah.
still need to know. When I do it, you still need to understand what it means. It will help you. Yeah, it will help you. So. And then, like for example, we have all these, fast food restaurants, calorie, right? And, the sample mean is 776.3 calories. The standard deviation is 385.1. So we want to know how far is Burger King from the average in standard deviation? How many standard deviation? So actually Burger King is less, the calorie is less than the average, right? And the Burger King's Whopper, not the triple Whopper. So that one, and then we just use the 670 divided by the average. And then, minus average divided by the standard deviation. So that's negative 0.276 standard deviation away from the average. Okay, so I'll show you later on. So that's what we get the Z. And why is it important? We will know later. Okay, yeah,
So I have a question in general.
yeah.
Are you reviewing all this stuff to later go back to? Because I took statistics and you're reviewing probably my entire statistics class
Are you serious?
in this class here. Yeah, this is like most of my statistics class.
This is like the beginning.
Well, I'm saying anyone who didn't take statistics, I understand what's happening here because I took statistics, but if someone didn't, they're gonna be entirely lost.
Uh-oh, anybody didn't take statistics? Who didn't take 110 or 111?
I'm just saying anyone who didn't ace statistics is gonna be lost right now.
Anybody is lost? Nobody is there to tell me? This is just, okay, this is not reviewing though, this is just to give you the concept. Okay, we will do more stuff, but it's just I want to show you. This is how we do the Z and Y. So we use this number minus the average. So in your statistics. But thank you
We did it
for,
all on calculator though. We ain't do all that hand stuff that you're
you
doing.
didn't? What did you guys do?
Calculator,
But,
bunch of formulas on the
but
calculator.
then you should learn more.
Not,
if you
not by
use-
hand, nobody trying to do all that on the.
So this is why we need to, like, this, we don't need to know this now, but I try to explain the concept. So this is the average, right? The average is 776.3. And we want to know how far is the Big Mac from that. Okay, so Big Mac is 540. So this, when you use this minus this divided by the standard deviation, which is negative 0.61. So that means this is negative 0.61 standard deviation away from the mean. And then, why is it important? It's not important now, but the reason it's important is because when we use the normal distribution table, we can know what is this area. And then we will know, we can know, like, in business, we will know, okay, this is our, not in calorie, but let's say whatever we make. And we know, okay, this is the average we want to reach, and we are only here, so how many percent, you know, we are away from this. Okay, so that's why we need to know this concept. Because in business, we need to use the, like this, okay, so the Z. This is plus minus 1 standard deviation. So when we have plus minus 1 standard deviation, we usually include 68% of the data. Okay, so when we are, let's say if we want to produce a water, we want to make a bottle of water. Okay, we want to make 16-ounce bottle of water. And the middle, it will be 16 ounces. And then let's say the standard deviation is 5 is good, not good. Negative, I mean, positive, 0.5. So whatever water bottle is filled, 15.5 to 16.5% ounces will be acceptable. But if the 0.5 is the standard deviation, that means only 68% of chance we're going to fill up our bottle between 15.5 to 16.5. Okay, so that's when we need to use statistics in business. So when we try to control the quality, we need to use that. And we need to, if that's the case, that means it's not acceptable. That means 32% of our product will be defect, will not be meeting the quality requirement. Okay, so that's why we need to know this for now. But in statistics, if it's a systematic fair share distribution, 68% is within plus minus 1 standard deviation, 95% is plus minus 2 standard deviation. 3 standard deviation will be 99.7. So usually, I don't know if you guys heard of 6 sigma. No? So 6 sigma is plus minus 6 standard deviation. They include 99.99999 something 7. So only 3 out of 1 million products will have defect. That's 6 sigma. And that's why in business, we want to pursue the 6 sigma quality. So if you go to, like, if a company say they have 6 sigma, that means the quality is very, very good. And if you go to a hospital, that means the hospital maybe have some mistake. 3 mistakes out of 1 million patient. Okay, so that's actually very good. Compared to this one, compared to 99.7%. So 99.7% is plus minus 3 sigma, 3 standard deviation. So it's only 0.3 defect, but if you apply 1 million patients in 0.3%, what is it? 3% of 1 million is 30,000, right? 30,000, and then it's 3,000. So that means 3,000 patients who experience some kind of error in the hospital out of 1 million. It's a huge number.
Hmm.
But if it's becoming Six Sigma, it's only 3. So that's why it's important.
It's only 3%.
3 in 1 million. And then this one will be,
I thought you said that was a lot.
Huh?
3,000.
yeah, 3,000 will be a lot compared to 3. Right?
Yeah.
But even 3,000, if we look at this number, 99.7% is good. It's actually very good compared to 68. But in some industry, it's not good enough. So that's why, that's why it's important to study statistics. So, but before we do all the calculation, there's this guy. He said, other distribution table, if it's not normal distribution, we can use this. Who can read this? Chebyshev's, okay? Chebyshev's formula. So basically, 1 minus z squared, 1 over z squared times 100. That will be the percentage. So if the z is 2, the z we calculated just now is 2. So that's 1 minus 1 over 4. So that's 75% of the data falls in 2 standard deviation. Okay? If it's a 3, it's 89. Okay? So that's that. So that's the Chebyshev's formula. When it's not the normal distribution. When it's normal distribution, like the bear shape, then the 1 standard deviation is 68%, 2 will be 95, 3 will be 99.7. Any questions? So this one, we will go over really quick next time. Okay, any questions? No questions? So I'll go over this next time, but, we have group data. So next time we will go over this and the group data. Okay? And then try to show up tomorrow, 5:30 at the piers. Piers.